Introduce you to logarithms and use logarithms to convert from exponential form to logarithmic form and vice versa. So far in algebra, we've solved various types of equations, and in this particular unit, we're going to be solving equations where the variable is an exponent sometimes. And the methods that we've learned in the past won't necessarily work in these situations. So we have to introduce logarithms. And logarithms allows exponents to come down as a normal term, and then and only then we can solve them in our regular methods. So, and that's because logs are considered to be the inverse of exponential functions, and exponential functions are the inverse of logarithmic functions. Just remember, when you want to get rid of a number exponent, you use a root. But if you want to get rid of a variable exponent, you have to use logs. The formula that we're going to use to convert from one format to the other is in the box below. So if we have exponential form, we have some base, some power, and that'll be equivalent to some number. Well, using that same lettering, we can write it in logarithmic form. The only thing that's slightly different is we introduce the word log. Notice that the base letter or number is still there, except for instead of it being large, it's written as a subscript. Then the number comes next in logarithmic form. Make sure you skip some space in between your subscript and the number or the answer. And then it's going to equal your power. So all numbers and stuff are still going to be involved. However, they're just going to be positioned in a different way. But it's not really too complex. And this lettering sequence that we're using, the B, the P, and the N, may not be what your textbook has, and it may not be what you find if you were to do a Google search. So don't be alarmed if they use a different lettering system. Just pay attention to the locations of things and you should be okay. Every time you write a log, make sure you write a base. If the base is invisible, it is considered to be a base 10. So if it's supposed to be a base of any other number, make sure you include that number there. Again, leaving a blank log is not acceptable. All logs have to have a base. And when writing your logs, if this was lined, the LOG portion and the N portion should be the same size on that line. And then the B again is a little subscript, and there's some space in between the B and the N portion. So let's practice. So in this first set, we're taking these exponential equations and writing them into their logarithmic form. So they're exponential, so let's establish who is who. So our base is 4, the power is 2, and our number or our answer is 16. So knowing all of that, again, logarithmic is log subscript base of your number equal to your power. With that being said, in this particular case, it's going to be log base 4 of 16 is equal to 2. And that would be the answer. That's it. That's all you need to do. One form to the next. Again, the way you read it is log base 4 of, the of is what kind of fills in that space. So log base 4 of 16 equals 2. So get in the habit of saying and reading the equation correctly as well. So for the next one on the right, my base is 5 this time. My power is 3, and I'm sorry for the handwriting. My number is 125. So in logarithmic form, it would be log base 5 of 125 is equal to 3. Sorry, my pen is doing whatever it wants to do. On the second set, we have logarithmic forms that we're going to convert to exponential. And when you're converting from logarithmic to exponential, it's a little easier because there's less things to write. And actually, when you convert to this format, you're actually forming an E. Watch this. The E starts at the base. So go from your base to your power, from your power to your number. So it's kind of a backwards E. So again, base to your power, power to your answer. With that being said, our base is 7, our power is 2, our number is 49. So if I flow in that manner, in exponential form, it would read 7 to the power of 2 is equal to 49. And done. Same thing on the right. Start at my base, base to my power, power to my answer. Backwards E. So my base is 4, my power is 3, and it's equal to 64. There's not a cute, clever way for going from exponential to logs, unfortunately. Sorry. For our third set, we have either exponential or logarithmic, and we need to convert it to the different format. And then we need to solve for x. So 3 to the power of x is equal to 8. So this is an exponential form. So to put it in logarithmic form, let's establish that our base is 3, our power is x, and our number is 8. So in logarithmic form, it would say log base 3 of 8 is equal to x. Oftentimes, a lot of y'all don't like x on the right, so if you want to move it, by all means, go for it. So you can read it as x is equal to log base 3 of 8. Same difference. Doesn't matter. Answer, that is the exact answer. X is equal to log base 3 of 8. But if you want to approximate, you would have to put it into the calculator. Now you would need an 84 or above to be able to type it in exactly like I have it written. A normal scientific calculator cannot do that. And yep, that's pretty much it. I don't have the calculator on my new computer, I'm sorry, so I can't demonstrate how to type it in. But I can tell you that on an 84 or above, you would hit alpha, I'll get back to you. I will, I'm sorry. As I was stating, if you have a TI graphing calculator that is an 84 or above, you should be able to press alpha window 5 to produce the log function or feature. That's one way of getting there. There's others, but that's probably the fastest. All right. And when done correctly, the answer is going to be 1.893. Again, when done correctly, the answer would be approximately 0.893. Oh, now my pen is tripping. Stop it. All right, there we go. So that's the approximated answer. Again, the exact answer was x was log base 3 of 8. The approximated answer is 1.893 if done correctly in a calculator. Now, when you look at a calculator, you're going to notice that there is an log button, a logarithmic button. That logarithmic button is only for logs that have a base 10. So our previous problem was base 3 log, so that's why I couldn't use that button. So make sure you're careful. Yes, there is a log button on any calculator, any scientific calculator, but that log button is only for base 10s. And if you want to be able to use that calculator to answer this question, there's more steps that need to be done. Just keep that in mind. All right, our last one on the right is a logarithmic equation, so we need to convert it to exponential. So we can draw our e, start at our base, come around to our power, and then we have our answer. So 10 to the power of 2 is equal to x. So again, if you want x on the left, you can change it. So x is equal to 10 to the power of 2 in this problem. So that means x is equal to 100. So that's the solution for x on that equation. So this concludes your introduction to logarithmics. Good luck.